Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 7th grade topic, permutations and combinations. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 7th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 6 parts, so leave a like, smash subscribe, and let's get started. Before we begin, let me warn you that both permutations and combinations rely heavily on factorials. If you are very weak or if you don't even know what a factorial is, I recommend you don't necessarily jump into this video right away because you're just going to confuse yourself. Pause this video, check out my first 2 videos on what a factorial is and even how to divide them, because both of those are going to be super helpful in understanding how we're going to attack permutations and combinations. Once you have that under your belt, come back to this and you'll see how it makes so much more sense. Now that we've gotten that out of the way, let's jump into our permutations. If you had seen my first video on factorials, you may remember that I said a permutation is just going to be how we calculate how many different ways we can arrange a given number of items. So for example, if we have something like 4 factorial, that's just going to be the number of ways we can arrange 4 different items. That's it. 4 factorial is the number of ways we can arrange 4 different items. Or, in other words, the number of permutations you have for 4 different items. If you had 3 factorial, that's just going to be the number of different ways you can arrange 3 different items. But factorials assume that we want to rearrange every single item that we're given. But there are times where we don't want to do this. Let's say we had these 3 items, but instead of trying to figure out how many different ways we can arrange all of them, we wanted to figure out how many different ways we can arrange 2 of these 3 items. Now that means any 2 of these items. What are the total number of ways we can take 2 items from this pool of 3 items and rearrange them? Now, what does that look like? And how is that different from simply doing a 2 factorial? Well, let's first break down what 2 factorial looks like. Well, 2 factorial assumes that you only have 2 items and you want to rearrange those as much as you possibly can. Well, there are only going to be 2 different ways you can rearrange 2 items. You can have the black one first and the white one second, or the white one first and the black one second. There's no other way you can rearrange these 2 items. This is going to be your 2 factorial. But now we have 3 items, and we want to know how many different ways we can arrange any 2 of these items from this pool of 3. So what is that going to look like? As you see, we have 6 different ways we can order 2 items when we have 3 originally. Now this is going to be very different from our 2 factorial because we only had 2 items to choose from. Once we ordered those 2 items, there was nothing else. However, once you order 2 items here, there's another item to choose from. That presence of a 3rd item adds a little bit more variety. And this just keeps growing as you have more items to choose from. So you see, trying to find the number of permutations you have when you choose 2 out of your given 3 items is very different from simply doing 2 factorial. We're going to need something more than just our simple factorials in order to find out how we can find these permutations. But before we move on, there's one thing I really want you to take note of. Note that order matters here. You see, we have coin first, white die second. Here we have white die first, coin second. This is very important. These are 2 distinct orderings for permutations. Same thing for the black die and the coin. You see, black die first, coin second. Coin first, black die second. 2 distinct ordering. It's important that you get that because we're going to revisit this when we talk about combinations later. For permutation, ordering matters. So like we just said, we're going to need something a little bit more than simple factorials in order to find these permutations. So let's start with some notation for our permutation. We have a big P, small n down here and a small r right here. Now the small n is going to be the number of total items we had. In our previous example, that was our 3. The big P tells us that we're going to be looking at a permutation, not to be confused with combinations, which we'll do in a little bit. Now r is going to be the smaller number of items that you're choosing to order from the original set n. R is going to be less than or equal to that full number n. So taking into account our previous example, we would have something like this. Remember, we had 3 total items and we wanted to figure out how many different ways we can order any 2 of those items. So we would have a 3p2. We have 3 total items, we choose 2 of them, and we're doing a permutation. Now the rest of the formula looks like this. We have our n factorial all over parentheses n minus r parentheses factorial. So if we were to plug in our numbers, we would get something like this. 3 factorial over 3 minus 2 closure parentheses factorial. And if we were to simplify this, we would get 3 times 2 times 1 over, what's 3 minus 2? 1. 1 factorial is just going to be 1. Now what is 3 times 2 times 1 divided by 1 going to be? Well, that's going to be 6. And we see that that's going to be the same exact number we found with our visual that we just looked at. We had 6 different ways of arranging 2 out of our total 3 items that we had. So this is going to be the formula we use when we're trying to find our permutation. Remember, n is going to be the total number of items that you have, and r is going to be that potential smaller set that you're trying to order from that total number that you had. So let's use this formula to tackle one example before we move on to our combinations. So our permutation example reads as follows. In a production of Grease, 8 actors are considered for the male roles of Danny, Kenickie, and Marty. In how many ways can the director cast the male roles? Now remember, order matters because whether you're Danny, Kenickie, or Marty, you're going to have a very different role. Even if the same 3 people are chosen for the top 3 roles, they're going to be very different roles depending on which one they get. That lets us know that this is a permutation. And if you think back to our formula, we need to figure out what our n is and what our r is. What's our total number versus what's our smaller subset. Now we have 8 actors and we have 3 roles. So 8 is going to be our total n, and our r is going to be the 3 roles we have. So we can write our formula as such. We have 8 big P 3. And when we fill that stuff in, we're going to have 8 factorial over 8 minus 3 factorial. Now we can expand this out. And this is going to be 8 times 7 times 6 times 5 factorial. Now, I stopped right there for a reason. You'll see why. Our bottom is going to be 8 minus 3. Now, what's 8 minus 3? That's going to be 5. Now, 8 minus 3, 5 inside parentheses, 5 factorial. So we can put all of that over 5 factorial. Now, you may see why I kept this as 5 factorial instead of expanding everything out. Both top and bottom have a 5 factorial, so we can cancel out the 5 factorial. Now, what's left? Well, that's going to be 8 times 7 times 6. Now, what's 8 times 7 times 6? Well, this is going to be 336. This lets us know that if we have 8 actors for Grease, we can rearrange those 8 actors, choosing 3 of them for our top 3 roles, 336 different ways. So now that we've talked about permutations for a bit, let's move into combinations and see how they're similar yet different from permutations. When talking about combinations, let's first start with the visual that we use when we discuss permutations. Like we said previously, if we have 3 total items and we want to find out how many different permutations we would have if we choose 2 of those 3 items, we would have 6 different permutations. However, the biggest difference between a combination and a permutation is that permutations, order matters. For a combination, order does not matter. Now, what does that mean for us? Well, that means that this right here, where you have black and then coin, is going to be the exact same as if you had coin and then black. This combination, the order doesn't matter. You have a black and you have a coin. That's all that matters. So you wouldn't have this right here. That goes off screen. Likewise, here you have a white die and you have a coin. Well, here's another white die and a coin. Order doesn't matter, so you wouldn't have this. Off screen for that one as well. And in this case, you have a white die and you have a black die. which is the same as this. It doesn't matter the order. The fact that you have a white die and a black die means that you don't need that second one. Off screen you go. This lets us know that we effectively have 1, 2, 3 different combinations when order does not matter. That's why it's important to remember permutation, order matters. Combination, order does not matter. What truly matters is the presence of those two items. If you have these two items already, you can't have them again. If you have these two items already, you can't have them again, and so forth. So let's look at what kind of formula we're going to have for our combination. So the notation for combinations are going to be very, very similar to what you saw for permutations. You're going to have that N. However, instead of having that P for permutation, you're going to have a big C. And they're going to have the same R. And they're going to mean the same thing. The total number you have versus the smaller number you select. The big difference is the big letter in the middle. Is it a permutation or is it a combination? That's the notation. So for our previous example, we're going to have 3 big C 2. Now the rest of the formula is going to be as follows. We're going to have n factorial in the top once again, and we're going to have the same parentheses, n minus r factorial. However, we're going to have an additional r factorial that we're multiplying this by. Now it's important that you know you cannot combine them. They're very different factorials. You do not combine these factorials. This is going to be 1 factorial multiplied by another factorial. So when we plug in our numbers into our combination formula, we're going to have 3 factorial over 3 minus 2 factorial times 2 factorial. And then we're going to get 3 times 2 times 1 over, what's 3 minus 2? Well, that's 1. So 1 factorial is just going to be 1 times, what's 2 factorial? 2 times 1. Now that we've expanded everything out, we can cancel what we need to cancel. There's a 2 times 1 in the top, so we can get rid of that. What we're left with is going to be a simple 3. And we just saw that visually, we had 3 different combinations when you had a total number of 3 and we chose 2 of them. So this lets us know that we're going to be using this formula when we're trying to find our combinations. The main difference between the formulas for combinations and permutations is that combinations is going to have this extra division here. So you can even think of this as NPR divided by r factorial. That's just another way of seeing this in respect to our permutation formula. But you don't have to commit that to memory. As long as you have this, that's all you're going to need to handle any of the examples that you're going to have. Well, speaking of examples, let's use our formula we just talked about to figure out how many different combinations we have in our next example. So our combination example reads as follows. You are on your way to Hawaii, aloha. And of 15 possible books, your parents say you can only take 10. How many different collections of 10 books can you take? Well, remember, we need to figure out what our N is and what our R is. Our N is supposed to be our total number of possibilities, right? Well, 15 seems like it's going to fit that bill. 15 is the total number of books that we have, but we can only choose 10 of them, which means that our R is going to be 10. So we're going to plug that into our formula and see what we get. So we're going to have our big C, and we're going to have a 15 here and a 10 here, which means that when we plug it in, we're going to have 15 factorial over, we're going to have a 15 minus 10 factorial times a 10 factorial. Then we can expand this out. So we're going to have 15 times 14 times 13 times 12 times 11 times 10 factorial. Now I'm stopping there for a reason, and you may already see why. Now we can expand this out. This is going to be 15 minus 10 factorial. Well, what's 15 minus 10? That's going to be 5. So 5 factorial. So we can have 5 times 4 times 3 times 2 times 1. 15 minus 10 is in parentheses. Make sure you do that first, and then you do your 5 factorial. 5 factorial expanded out is going to be this, times, I'm going to keep this as 10 factorial. We're going to keep that same 10 and carry it over. Now we can simplify. Well, we have a 10 factorial on the top and a 10 factorial on the bottom. we can cancel out our 10 factorials. We have a 3 times 5, which gives us a 15. We can cancel that out. Well, you have this 4 out of the 12, left over a 3 on top. We also have this 2 out of this 14, left over 7 on top. Anything else? Not really. So we're going to rewrite this as 7 times 13 times 3 times 11 all over 1. 1 is the only thing that we have in a denominator that hasn't been crossed out. And this is just through simplification. You don't have to simplify. You can throw everything in your calculator if you feel like it. But to simplify a little bit to make sure what you're putting in your calculator looks a little bit cleaner, you can do this. But if this confuses you, heck, throw everything in your calculator as you need. We've already gotten rid of all the factorials. These are just going to be simple numbers that you're multiplying in your numerator and your denominator, and then you can divide it as you need it. But if you're following along with the simplification and you got to this step, just plug this into your calculator. There is no need to put any divided by 1. Just plug everything into your calculator and you will see that you're going to get 3,003. That means if you had 15 books that you could possibly bring on this trip, but your parents tell you only choose 10, there's 3,003 different combinations of those 10 books that you can bring on your Hawaii trip. I recommend don't try to figure out all of them. Well, I hope you were able to follow along with today's examples and hope you now know the difference between your permutations and your combinations. However, if you have any questions about what we saw today or even your own homework, you can put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.